very simple observation. It's about geometry. Everyone learns geometry, especially learn triangle, right? If I have a midpoint here, another midpoint here, and you draw lines, what do we call this line? Anyone tell me?
A line.
This line, bisector. Either line, midpoint, and this is an arbitrary triangle. And I'm telling you, this is midpoint A. What do you call the CN then? Yeah, go ahead. This is an altitude. It may not be right angle. Go ahead. Pardon? I said altitude. No, it may not be right angle. Could be arbitrary. Go ahead. Median. Good enough. It's median. We call median here. There's another median too. 2 median meter point. And this is center. It's called central. If you lay out a piece of paper along the thread at the midpoint here, what happened then? They're going to be balanced. All right? They're going to be balanced. That balance means equal weight on both sides. That's why you get balance. Now, how about the other one? You do the same thing too. So this is going to be intersection of two special lines. Now, I don't want to use any thread anymore. I use a pinpoint or any kind of needle. I support the triangle at this point. What happened? What happened? The triangle will balance at the point. That's why this is the point of, this is the center of mass. This is the center of mass. It will support the whole triangle if only get balance. Now we want to study this property of this special point. Can anyone tell me now what the ratio between these two distances for 2 seconds? Go ahead.
1 to 2.
1 to 2. How about you? 1 to 1. I know my drawing is not scale, but it's not at all. It's better than 1 to 1. Go ahead. 2, you mean this is 2 to 1? What did you read? Well, that would be 2 off, really 2 off. The answer is, we have to see that. How do you see this 1 to 2 or 2 to 1? How do you see that point? So today, that's going to be our main subject of learning is a special property of this. Let me draw another triangle for you. I bet you learned this before. Midpoint and midpoint. If I connect these two points, what do I call this one? It's called mid-segment. This mid-segment is parallel to the base. Can anyone tell me now how is that related? The mid-segment with the base. Yeah, go ahead.
The mid-segment is 1/2 of the base.
That's perfect answer. 1/2 of the base. And how do you see that? How do you see that? Your answer is correct. Perfect. If you can give me an explanation, I'll give you an extra point on that. By the way, today is Friday. If you want to catch all your points, anything you learned today, you're going to catch all your points. Midpoint of 2 sides? That's why how do we prove that? Or how do you see it? I want to show you here right here. If I find a midpoint 2, and I'm going to draw line like this, you're going to see that. Don't you see that now? This is the parallel. This is the parallelogram. This is also a parallelogram on both sides. No matter what, this is congruent to that, and this is going to congruent to that. So this is the midpoint. Again, this is 1/2 of that, right? This is 1/2 of that. But how about this then? How about this? How about this? We're going to see that point right now. I would like you to see this point. If I draw a line right here, what do you see? You see this is a parallel line to the base here, right? And because it's a parallel line, I want you to see some nice fact here. This angle and this angle, how are they related? Yes, go ahead. Same angle, same measure. We call congruent. That's correct. So this is the alternate interior angles. They are congruent. And how about this angle too? Just the same thing. So now what do you see? And this angle is also congruent to the angle, right? Yes. Because the vertical angles, they gotta be congruent. So what do we conclude? These two triangles, they are similar. because all the respective angle they are congruent, they are identical. Now what's next? Because this side is half of this 1 to 2 ratio. We just see that before, right? We just see it before. What do we conclude about this and that? Indeed, this is 1 to 2. Indeed, this is 1 to 2. So you just see that. It's 1 to 2. 1 to 2 ratio is I just showed you here. This is indeed possible. Now I want you to see this that if I do not want to go through this route, I want to show you some even faster way to see it through. Again, this midpoint and this midpoint. Today the competition is going to hinge on this method, so you want to listen very carefully. You want to listen very, very carefully. I want to see that this is midpoint, and I want to draw a parallel line to this line. So let me label it. This is called A, B, C, N, and N. Now I want to draw another point, another line, which is parallel to B, N. What do you see? What do you see? This is a midpoint, so this is a congruent. You see? Now tell me now, if this point we call P, can anyone infer anything special about APPN? Anyone? Anyone can tell me that? Because this is congruent, because this is a parallel line, I want you to see this a triangle only. Okay, let me insert the triangle. You'll see better what I'm seeing. What I want you to understand it is, this is the midpoint, this is the midpoint, this is the parallel line. I draw it against the other side. See, this is congruent, this is a parallel line. Is going to induce this is going to be equal. Do you follow that? So this can be midpoint. Let me say it again. From the midpoint, I draw a parallel line against the base here. I'm going to meet at the midpoint of the other side. It's guaranteed. So now what do you conclude? This is the midpoint. P is the midpoint of AN. And now what's the next? I want you to see this. Since this is the midpoint, this is going to be 1 to 1 ratio. You agree? Yeah. Now how about 1 plus 1? 2. Of course it do. Because it looks so trivial. But listen, the fact is just so trivial. So what do we conclude about this side?
It's 2.
Perfect answer. It's 2. Now here's the magic. I want you to see this fact here. Just 1 point away, you see the fact immediately. I want you to zoom into this triangle now. What do you see? Now let me clean this out. Let me clean this out. You see the fact immediately. What do you see? You see this side is 1 to 2, right? Do you see this triangle? Do you see this triangle? Yeah. See, this is 1 to 2. How about this side? It got to be 1 to 2. Because the parallel line always induce the same ratio on the other side. So this is 1 to 2. No, I just prove it again. This side, the centroid is located at 1 to 2 ratio. This is centroid because the midpoint, this is midpoint here, and there's a midpoint here. That's why the two medians meet at the centroid. So again, this is the second proof you just see. This is the 1 to 2 ratio. All right. I want you to learn the technique I use here to find out the ratio precisely. I'd like you to start with this competition. Are you ready?
Yes.
Here's the competition now. Here's the competition. In an arbitrary triangle, you can mimic whatever I get, and then use it here. This is not midpoint anyway. It becomes each one. I change it, become 1 to 2 ratio. And I want to change it on to be still 1 to 1. 1 to. It's still easy case because this is the beginning. I don't want to be too rough. So I want you to see the point now. When I change to 1 to 2, and this is still 1 to 1, I want you to recalculate the ratio of A to B. Go ahead. I'm gonna offer you another 100. Let's check it out. See the mean? Instead of drawing toward way, you're gonna draw toward the other way. Right? How do you draw them?
From the perimeter of C and 1.
How do you draw? You're gonna draw from this point.
Yeah.
You draw the point, and then with the parallel to this one, right? To the base here. So we're gonna do this. We're gonna do this. We're gonna induce a ratio on the opposite side. And so this is a 1 to 2 ratio. 1 to 2 ratio. 1 plus 2? 3. So we're talking about this as 3.
Oh, was that wrong?
You agree? And then this part is 2. This my 3. So 2 to 3 is 0. 2 to 3 is guys, you got it right. 2 to 3 are right. 2 to 3 is right. So guys, you are expert now.